Hi, welcome to Math After Hours with Miss Austin. I'm Miss Austin, a math teacher here to help you with any math problems you may have. Today, I'm going to show you Cramer's rule for a system of 3 equations. Cramer's rule is just another way to solve a system. So you may have learned substitution, elimination, solving by graphing. There are tons of ways to solve a system. Cramer's rule is just another way. Okay. So up here I have Cramer's rule for a general 3x3 system. I've used A, B, and C for my coefficients, A2, B2, C2 for the second equation, A3, B3, C3 for the third equation. Now, if you do not know how to find a determinant, or if you do not know what a determinant is, I have a video for how to find the determinant of a 3x3, and I recommend going to watch that before you come back to this video. Okay, so we have a few different determinants we're going to have to find here. The first one is D, which is the coefficient determinant. Now this is very important because if this comes out to 0, then Cramer's rule will not apply for this system. So then we would stop at that point and you'd have to try another method. The next one is D sub x. What happens here is you're going to replace the first column with the constants from your system. Then D sub y will be when you replace the second or the y column with your constants. Similarly, D sub z will be when you replace the last column or the z column with your constants. And then once you have all those determinants, you can find x, y, and z by dividing that specific determinant over d. So I have an example for us down here. Cramer's rule is kind of tedious. That's just the way it is. So I'm sorry if you have to use Cramer's rule. It just takes a while, and that's how it is. So the first thing we are going to find is d. This is the coefficient determinant. So we're going to put in 1, 1, negative 1. Those are the coefficients for the first equation. Then 3, negative 2, 1. And 1, 3, negative 2. And like I said, if you don't know how to find a 3x3 determinant, I have a video for that. So jumping right into that, these numbers across the top go in front of each of the 2x2 determinants. So 1 will be in front of the first. And to get those values, you cross out the row and column that's in. So negative 2, 1, 3, and negative 2 will go inside. The middle one is a minus 1, because that's the second number across the top. Crossing out that row and column, we're left with 3, 1, 1, negative 2. And then the last one, we'd have plus a negative 1 or just minus. Crossing out that row and column, you'd be left with 3, negative 2, 1, 3. So there's a few 2x2s here. This will be 1 times negative 2 times negative 2 is 4, minus 3 times 1 is 3. And we have minus 1 times 3 times negative 2 is negative 6, minus 1 times 1. And then minus 1 times 3 times 3 is 9, minus a negative 2. So this is 1 times 1 minus 1 times negative 7 minus 1 times 11. So this is really 1 plus 7 minus 11, which is negative 3. So that is the value for D. And since that value is not equal to 0, that means we can use Cramer's rule. Okay, so next one is D sub x. So what we do is we take this determinant right here, and we're just going to replace the first column with the constants from the equation, which in this case are 6, -5, and 14. So we'd have 6, -5, 14. Then the other numbers are the same. 1, -1, -2, 1, 3, -2. Okay, so setting up these 2 by 2s, 6 goes in front of our first one. Inside we have -2, 1, 3, -2. Then -1 times -5, 1, 14, -2. And then plus a -1, so -1 times -5, -2, 14, 3. So this is 6 times -2 times -2 is 4, -3 times 1, which is 3, -1 times -5 times -2 is 10, -14, -1, and then we have -5 times 3 is -15, minus 14 times -2 is -28. Okay, so this is 6 times 1 minus 1 times -4 minus 1, and then this is really -15 plus 28, which is 13. So we have 6 plus 4 minus 13, which is -3. So we can actually find the value of x now because we have d and d sub x. And it tells us right here up at the top, x is d sub x divided by d. So it's -3 over -3, which is 1. And this is why this is tedious, because we only have the x value. You still have to do this for y and z. So stick with me. Okay, so for d sub y, this time we replace the second or the y column with the constant. So those will go in the middle. And then the first and third columns will be the same as in our original coefficient determinant. So this is 1, 3, 1, -1, 1, -2. Okay, so we're going to have 1 times the determinant of -5, 1, 14, -2, minus 6 times the determinant of 3, 1, 1, -2, plus a -1, so -1 times the determinant of 3, -5, 1, 14. So this is 1 times -5 times -2 is 10, minus 14 times 1 is 14, minus 6 times 3 times -2 is -6, minus 1 times 1 is 1, and then we have -1 times 3 times 14 is 42, minus 1 times -5 is -5. Simplifying, that's 1 times -4 minus 6 times -7 minus 1 times, that's really 42 plus 5, which is 47. So this is -4 plus 42 minus 47, and that gives you -9. So now we can find the y value, because y is d sub y over d, which we now know is -9, over -3, which is 3. Finally, one more step, and then we're done. We just have to find d sub z. So hopefully you can see the pattern now. The only column that's going to change this time is the third column. So we have 1, 3, 1, 1, -2, 3, and then we replace the third column with 6, -5, 14. So we're going to have 1 times the 2 by 2 of -2, -5, 3, 14, minus 1 times the determinant of 3, -5, 1, 14, plus 6 times the determinant of 3, -2, 1, 3. This is 1 times -2 times 14 is -28 minus -15 minus 1 times 3 times 14 is 42 minus a -5 plus 6 times 3 times 3 is 9 minus a -2. So this will be 1 times -28 plus 15 is -13, minus 1 times 42 plus 5, which is 47, and then plus 6 times 9 plus 2, which is 11. So this is -13 minus 47 plus 66, which gives us 6. So finally, we can find z by doing d sub z over d. That's 6 over -3, which is -2. So the solution to this system is x equals 1, y equals 3, z equals -2. Okay, if you stuck to the end, thank you. I know Cramer's rule for a system of 3 equations takes a long time. Personally, my students get mad every time I make them do Cramer's rule, but sometimes you have to learn new methods, right? So thank you for watching. Please like and subscribe. If you have any math questions you'd like me to do, please comment below.